Hello and welcome to Spectacular Science, Electricity. Tonight we're going to be learning all about electricity. So we're going to start out by asking, who's excited to be here? Who's got a lot of energy to be here? All right, show me your energy. Show me your energy. Show me how you're excited to be here. Awesome. All right, now time to put your listening ears on. So we're going to start with that little activity to get kids involved. Then we say, energy is one of those words that you know what it means and you can show it in your body. But if someone asked you, it would be really hard to say what it actually means, to define it. Well, scientists like to define energy as something that can make other things change or something that can do work. And there's lots of different forms of energy, but the type of energy we're talking about tonight is called electricity. And that's the type of energy that can make your TVs work, that makes anything work that you plug into the wall, like say your Wii game system or your hair dryer. It's also what changes your lights from being off to being on. And that's the form of energy that we're going to talk about. Might be a new word for you, so let's say it together. The word is electricity. Can you say electricity?
Electricity.
Very good. Now electricity is made by a ton of teeny tiny little bitty particles moving. These particles are called electrons. And when lots and lots of electrons are moving, that's when we get the energy that we call electricity. Now for electricity to work, there are 3 rules that we're going to talk about tonight. The first rule is you need a source of electrons. And one source is a battery. A battery is sitting there holding electrons just waiting to be flowing. Another source of energy are power plants. That's where we get the energy that will come out when you plug something into your wall. And if children ask, we talked about how batteries can store those electrons. If somebody asks, well, how does a power plant work? Or how does a power plant give us energy or give us electricity? This is a deeper question, but if it's asked, you can respond very simply, very quickly by saying that it begins as a mechanical movement, so like you have water flowing over a dam, or you have something being burnt or exploded that combusts, it expands, and that makes another piece turn or spin. And when that spins, it spins something that has wires on it inside a casing of magnets. And when you spin the wires in the magnets, that forms electricity. Again, that's a much more complicated question, but if you have an older child that asks something like that, you can explain it in kind of those simple terms. Right, so we have batteries are a source, our power plants are a source. Rule number 2 we're going to talk about. Electricity needs a circuit in order to travel. Now that's probably another new word. What does the word circuit sound like to you?
Circle?
Circle, very good. Now if kids aren't guessing it, then you can say circ kind of sounds like a shape that we know, and wait for them to say circle. Now I need a volunteer to come up. How about you? Come up and make me a circle with your hands. Okay, a circuit actually is a lot like a circle. You see this circle that she's making here? It doesn't have a beginning or an end, it's all connected. Everybody make a circle with your hands. So a circuit is like a circle in that it's all connected, and that it has to all be connected. But what's different about a circuit is it doesn't have to be this shape. It can be like that, and as long as it's still connected, it's still a circuit. So try and make some funny shapes. Oh, look, see, I made a heart-shaped circuit. You could do that. But the key is it has to be connected. It can't be broken. Our little poster shows that right here. So here we have the source where it starts, and this has to be connected all the way around through our little light bulb or whatever it is we're powering, and all the way back to the beginning. A circuit, completely connected, never broken. And if at any point your circuit is broken, then your lights go out. Okay? So any break in the circuit at any point and the lights go out. Even, and this is really interesting, even if the break is after the light bulb. Any break anywhere along this circuit and your lights go out. Okay? We don't want our lights out, so we're going to complete our circuit. Now we have a nice complete circuit, and our lights will turn back on. Okay, so that's rule number 2. Now we're at rule number 3, and that is that these moving electrons, not only do they need a complete circuit in order to flow, they also need a material that they like to move along. A material like that is called a conductor. Wires are really good conductors, so when you see your dad trying to fix something in the walls or trying to set up your sound system and he's got wires everywhere, it's because wires work really well to conduct electricity. Conducting is, again, another new word, but they just allow the electrons to flow more easily. Something that doesn't is called an insulator. All right, so that explains our rules and our basics on electricity. Now we have some hands-on activities to help you understand this concept a little bit better. All right, our first one has actually got quite a few activities with it. We have a great little flip chart here called Light It Up. And the first page is just a review of what we talked about. Again, there's a lot of new terms here for kids. And so, you know, when you can, if the kids are getting a little confused, you try to leave some of those terms out and just explain what they mean without actually using the new words. But they're also, some of them are defined in here to help review. And it begins with a pretty simple task, getting the flashlight to work. And this shows that you need your power source to get it to work, and they have to go in the right way so that the electrons can flow the right direction here. So we get your light, your flashlight on and working, and that's the first task that they need to perform. And then it goes into understanding a little better why the flashlight works. Can you use these supplies to also light a light bulb? So here are the supplies, and we have most of this done already and set up already, but we have wires. Again, those are what the electrons travel along. Our source, and the thing that we want to have do work, that we want to change. We want to change it from dark to light. So here we have, again, new word defined, circuit. Here we have the circuit completed. The electricity can flow and the light bulb turns on. Here we have some seeing what is a circuit and what isn't. If you connect it to here, that's not a complete circuit because there's a break from here to the end. You put to here, it works. Anywhere else along the wire, back at the beginning, it still doesn't work. So it has you try different configurations to recognize what a completed circuit is. And another new word, closed circuit, just meaning a complete circuit, a circuit that's all connected, versus open, that does not connect.